Core Image is Apple's framework for manipulating images. It's not drawing, or at least not for the most part. Instead, it's about changing existing images. That means sharpening, or blurs, or vignettes, or pixelation. If you've ever used Apple's Photo Booth app and worked with the filters there, you have a very good idea of what Core Image does well. However, Core Image does not integrate with SwiftUI very well. In fact, I wouldn't even say it integrates with Apple's older framework, UIKit, very well. Now, yes, I've added some helpers over time, but it still takes quite a bit of thinking. Please stick with me though. Honestly, the results are quite brilliant once you understand how it all works, and it opens up a huge range of new functionality for your apps in the future. Now, first we're going to put in some code to give us a basic image to work with, but I'm going to structure this in a slightly weird way. I'm going to create our image view as an optional @state property, then let it resize the filter screen, and then an onAppear modifier to actually load the image. So, first, add an example image to asset catalog. I have one here already, just called example. It's a Singapore airport, but call it example like I have here. And now, modify your code. First things first, we have a state property to store our image. It's not got a value by default, it'll be nil. So I'll say @state private var image is an optional image. And then I'll replace this current code with a VStack using our image with a question mark that's optional, then saying resizable, and then scale to fit. And then I'll apply an onAppear modifier here that will perform a method called loadImage, which we'll write now. This is going to simply say func loadImage. Image is a new image using that example value, like so. Boom. Now first, notice how smoothly SwiftUI handles optional views. It just works. However, also notice I put this VStack around the image for the onAppear modifier. This matters because by default, this image will be nil, and therefore it won't trigger the onAppear modifier. The VStack triggers the onAppear modifier. Anyway, that code, you can see our example image working just fine here, and it's neatly scaled to fit the screen. Now for the complicated part. What is one of these? An image. Now, as you know already, it's a SwiftUI view, which means it's something we can position and size inside our SwiftUI view hierarchy somehow. It also handles loading images from our asset catalog, like down here. Handles loading SF symbols as well, and can even load a handful of other sources as well. It's a powerful thing. However, ultimately, it is something that gets displayed. We can't write its contents to disk or otherwise transform them other than applying a handful of SwiftUI image filters. If you want to use Core Image, SwiftUI's image view is a great endpoint to end up with, but it's not useful elsewhere. That is, if you want to make images dynamically, you want to apply Core Image filters, you want to save them somehow, that SwiftUI's images basically aren't up to the job. You've got to do more if you want a Core Image filter applied here. Hey dogs. And cunningly, Apple gives us 3 other image types to work with, and you've got to use all 3 if you want to work with Core Image. Good dog. So there's SwiftUI's image, but there's 3 other ones, and all 3 are required to use Core Image. And brilliantly, they all sound very similar. Like, well, that's not the same thing again. Yeah, there is a subtle distinction between each one of these things, and it's important to use them correctly if you want to get something meaningful out of Core Image. So, here are the 3 types. Apart from SwiftUI's own image view type we've seen already, we also have one called UI image. The UI part means it comes from UIKit. It's an extremely powerful image type that can handle, you have that one, it can handle working with a variety of image types like pings or vector images or even images sequences that form animations. UI image is the standard image type for UIKit. And of the 3, it's the one that's closest, not the same as, but closest to image. As well as that, we have a second image type called CG image. The CG means it comes from Core Graphics. This is a simpler image type than UI image. It's just really a 2-dimensional array of pixels. So that's UI image and CG image. The third type is CI image. So UI image, UIKit, CG image, Core Graphics, CI image, Core Image. And this is special. This is not pixels. Instead, this stores the information required to produce a picture. It's a recipe. But it doesn't actually turn it into actual pixels unless it's asked to. And so Apple literally calls a CI image type an image recipe rather than actual pixels you can put on the screen. Now, there is some interoperability between these various image types. We can make a UI image from a CG image, and we can make a CG image from a UI image. They're basically interchangeable. We can make a CI image from a UI image and from a CG image, and make a CG image from a CI image. And we can make a SwiftUI image from a UI image and a CG image. It's a big bundle of confusingness, quite frankly. I know it's confusing. You're sitting there going, what? Yeah, I get it. It is confusing. But hopefully once you see the code, it'll be a little bit better. What matters? The only thing that really matters is these three image types, UI image, CG image, CI image, are pure data. They hold image information. We cannot place them to a SwiftUI view hierarchy. We can manipulate them freely, then present the results in a SwiftUI view. And so it's great for times you want to manipulate the data somehow before showing it on the screen somehow. That's it. That's 3 each. Off you go. Okay, we're going to change this load image method here. So it creates a UI image from our example image, then manipulate it using core image. More specifically, we're going to start with 2 tasks. First, we're going to load our image into a UI image. This has a very similar initializer. We just say a UI image with resource attached to it. Boom, it'll load .example nicely. Again, from the asset catalog. This will return the value, which is great. We actually work with it. And then we'll convert that into a CI image, which is what core image wants to work with. It's recipe input, as it were. So here, I'll replace this code with, so again, we're using UI image with resource, this one right here. We'll say, let our input image is a UI image with a resource of .example, like that. So grab our image to work with, and we'll put that into a CI image. That's a recipe thing now. So we'll now say, let begin image be a CI image with image of our input image. And then there's more code to come. And the next step is going to make a core image context and a core image filter. Filters are things that do the actual work of transforming image data somehow, such as blurring it or sharpening it or adjusting the colors somehow and whatever. And contexts handle all that information, all the caching information, to convert it into a processed CG image we can work with. So actually it runs a recipe, as it were. Both of these data types come from core image, so you can basically pull them in now with 2 new imports here. And so in our content view, I'm going to add an import core image and import core image .ci filter built-ins. These are the helpers to make loading more easily. And next, we're going to make the context and the filter. For this example, we're going to use a simple sepia tone filter, the sort of browny, whitey, old-timey color scheme here. And so we'll say, first, make our context, and then make our filter. So our current filter will be a CI filter .sepia tone. Load that filter, ready to use. And now you can customize the filter to adjust the way it works. Sepia is a very, very simple filter. It only has 2 actual properties we care about. One is the input image, the image we want to change in our recipe, and one is intensity, which is how strongly the sepia effect should be applied, where we have 0, no effect, through to 1, which is a full sepia effect. And so we're going to add 2 lines of code below this. We'll say our current filter, input image, is our begin image. And then our current filter, intensity, equals 1. Maximum strength sepia effect here. So far, none of this is really that hard. But here's where that changes. This is the complicated bit. I know it's really mangy, but we're stuck with it. We'll convert the output from our filter to a SwiftUI image we can display in our view. This is where we're going to lean on all 4 image types at the same time, because the easiest thing to do, trust me, you think, oh, why isn't this? No, the easiest thing to do is to read the output image from our filter, which would be another CI image. This might fail. Might be nothing in there. The recipe's gone wrong, so it'll be optional. We'll then ask our context to convert a CG image from that output image. This also might fail, so again, it returns an optional. We then convert a CG image, into a UI image, and then UI image into a SwiftUI image. So all 4 image types being used at the same time. Mangy is the right word for it. You can go direct from a CG image to a SwiftUI image, missing one step, but it requires extra parameters and just basically adds more complexities, which is why I'm not doing it here. So step 1, we're going to get a CI image from our filter or exit if that fails. So I'll say guard let output image be our current filter output image, else return. And then we'll attempt to get a CG image from our CI image, attempt to get that thing out here. So we'll say guard let CG image be a context dot create CG image. As options here you can see, we'll choose a simple one, image from. Give this thing a CI image plus the how much you want to read, the size of it. So we'll say read our output image and use the whole thing. Output image dot extend, the whole information here. Again, else return. So we can't read that either. Just bail out, okay? If we're here, I'll just call it CG image. There you go, bad name. If we're here, it means we've got the output image, we've made it into a CG image, we can now turn that into a UI image. So I'll say here, let UI image be a UI image with CG image of that CG image. And now we've got a UI kit, UI image, we can put that into a SwiftUI image. Our image is image with UI image of UI image, like that. Boom. So you can see straight away, I know it's a lot of work. I know it's confusing. Sorry, I'm apologizing I didn't make it, Apple made it, but it's not great. But you can see our effect is applied fully. A nice sepia tone image here, all thanks to core image. And of course it's customizable. So again, 0 is original picture, 0.5 is like half sepia, 0.75 quite sepia, 1 very sepia, whatever. It's customizable, okay? Now, you might think that was a heck of a lot of work just to get a fairly simple result. And you'd be right, I get that. But now you have all the basics of core image in place, it's relatively easy to switch different filters. There's other ones apart from sepia tone. We could just say CI filter dot here and just browse through the various filter names that are available. And there's stacks of them. These are all filters you can apply. Color blending, color curves, posterizing, dithering, whatever, Gaussian blur, gloom. There are lots of these things, which is clever. That being said, brace yourself, core image is a little bit, well, let's say creative. And it was introduced a while ago, okay? This is old stuff. We're on iOS 17 and I'm recording this thing right now. This was introduced back in iOS 5 and it's being made beforehand. So it's at least 12 years old, okay? And by that point, Swift was already being developed inside Apple, but you really wouldn't know it, okay? For the longest time, the core image API was the least Swifty thing you could possibly imagine. And although Apple has kind of slowly chipped away at its craft, sometimes you have no choice but to dig into its sort of dirty underbelly. First, the modern API. Okay, we could replace our sepia tone filter with something like a pixelate. I could say, let's do a pixelate filter here. Pixelate. Boom. So that's a pixelation effect, but it's saying, oh, there is no intensity anymore. Correct. There's now a scale. How big the picture should be. So I'll use 100. And you get like a really pixelated effect. Or 10. Slightly pixelated. Or 50, whatever, mid-range. So it's a great pixelation effect. And you'll see this thing has a scale, not an intensity. And now let's try a different one. Let's try, okay, I want to do not pixelate, but let's do a crystallize effect. Again, our code won't compile, there's no scale. Okay, let's do intensity. Oh, I haven't got that either. Cool, because this one has a radius. We'll do 200. And you see it makes that effect, or 20, or I don't know, 50. It's a lovely effect and lightning fast. Core image is very, very quick. But they're all different, right? Or you could say, okay, let's not do a crystallize, let's do a twirl distortion. And this does have a radius. You could say 1,000 in this one. Really strong effect, or 100 if you want to. That's the effect happening right here. Make it a bit bigger, perhaps. There you go. You can change the center as well. You could say current filter center is a CG point of X, our input image size width divided by 2, and Y input image size height divided by 2. Center on the middle of the thing, all being well. And it's having a go. It looks quite good. But it's obviously another set of parameters now. We've got censoring going on and similar. And so it's complicated. There's lots of variation here. So it's still good. I mean, there's a lot we can do with just a modern API. And it is telling you there's no intensity, no scale, whatever. It is being useful. But for this project, we're going to use the older API for setting things like radius and scale, because it lets us set values dynamically. We can literally ask the current filter, what do you support? And then send them on in. I'll show you how it looks. Don't worry, I'm almost at the end of this now. You're almost through it. Keep battling on. We're going to say, let's leave our twirl distortion in place. And then I'm going to say, we've got an amount property of 1.0. Amount meaning some unknown number, okay? We can now read the input keys for our current filter, like that. Read the things it actually supports. And then we'll use that to adjust the various inputs, okay? So let's leave our input image alone. That's not changing. That's fixed, like that. Boom. Here, I'm going to say, if our input keys contains, you can ask it, do you contain this value? Now, unhelpfully, they all have very, very specific names. This is things like K, CI, and then one of these things. You do KCI key. These are all possible keys you can insert. You can see here's radius here, here's intensity, here's sharpness, transform, brightness, saturation. There are loads of these things, and they're all specific names. That's how Apple used to work in the old days. We want KCI input intensity key. That one here. So if this is a filter that supports intensity, that's what we're saying now. If we have that, we're going to say current filter dot set value our amount for the key KCI input intensity key. Boom, like that. Makes a bit of space. There you go. So if you support intensity, set amount for intensity. That's what I'm saying here. And then I'll copy and paste it a little bit. Then we'll say, do you support input radius? Is that a thing you offer? If it is, set, don't crash, set the radius. Like that. Now for the radius, a value between 0 and 1 isn't very interesting. You want to increase the value here somehow. So I'm actually going to set amount and then say amount times 200, making that much stronger. Let's do one more. Here we have KCI input, scale key, set scale key, like that. And I'll say amount times 10. It's a bit of try and error, but you get the idea. Scale, not scale, scale. The try and error, but so set lots of radius and a little bit of scale here. And then I'll ditch center and radius. Just do it like that. So we're detecting exactly what this thing actually supports here. And now, because of this dynamic approach, we're saying, do you support intensity? Do you support radius? Do you support scale? Because of that, we can actually switch out twirl distortion for sepia tone. And it'll work. Or we could say crystallize, and that'll work. So they're all able to adapt because it's no longer setting exact values that may or may not be there. It'll adapt automatically based on what's actually supported by the current filter. Now, these things behind the scenes are really just a whole bunch of strings. This is a magic string, which refers to that intensity key. That's how Apple always worked for a long time. It's very similar to how user defaults works as well. These are all strings behind the scenes, so it's actually so similar the way. This is Apple's old school way of working here. Anyway, If you're implementing precise core image adjustments, please use the new API where it'll say, oh yes, you support intensity and this, but not scale, not radius, whatever. Okay. Exact names, exact types is very, very nice. But in this particular project, we're going to switch between many different kinds of filters very quickly. And so the old API comes very, very useful here. It lets send in adjustments regardless of what actual filter is being used.